Hello everybody. Welcome to Creating the Basic Adaptable Game Engine Library, Part 30, Sprite Mirroring and Flipping. Now, sprite mirroring and flipping refer to reversing the way a sprite image looks. For example, when you look in the mirror, you might notice that your left and right sides appear reversed. Similarly, if one is to flip something upside down, that means to switch the top and the bottom directions, interchanging them. So sprite mirroring refers to reversing something along the x direction, and flipping refers to reversing something along the y direction. So we'll make a change to the sprite class, which enable us to mirror and flip an image. Now, usually this is most useful in side view games, right? Especially for sprites that don't have rotational symmetry. And by that, I mean, if we took our turtle character, and if we were to mirror or flip it, it would just look like it's facing in a different direction. And we can accomplish that using the rotate by functions. But for other sprites, it's not as clear if you could accomplish a required or a desired transformation just by using rotation. That's a lot of words. Let me show you an example. So returning to our development environment, maybe we'd like to add a new character to our game. So one of the graphics I have included in the images directory is the image of a shark. Let's go ahead and let's add a shark to this game. First, let's create a new sprite at the beginning of our class called shark. In the initialize method, we'll set it up. We'll just put one in the middle of the screen. And so let's say shark. Let's do this before the win message. In fact, let's do this also before the starfish as well. I mean, in theory, you'd set up the starfish so they don't overlap the shark either. We'll say shark is equal to a new sprite, shark.setPosition. We'll want this to be in the middle of the screen, so 400, 300, and shark.setTexture to be a new texture object. From the images directory, there's something in there called shark.png. PNG file because that supports transparency. And then to the main group, we'd like to add a shark. All right, let's go ahead and give this a run just to make sure that that shark adds in correctly. All right, we should just see a shark. It's kind of hanging out. All right, he's hiding in wait underneath those starfish. Right now we haven't really added any code. And this shark is, well, it's a very mellow shark, right? It's not reacting to our presence at all. It's extremely non-threatening. So what we'd like to do here is, maybe we'll have the shark face the turtle. There's a few ways to do that. I'm going to do a particularly simple way. Maybe if we're on the left side of the screen, if the turtle is to the left of the shark, we'll have the shark face to the left. And if the turtle's to the right of the shark, we'll have the shark face to the right. Right, so at least it'll be looking at the correct half of the screen. Now by default, it's good when you're choosing images to use for your sprites, always have those images, if they represent characters, make them face to the right. So in this case, we'll want to set the angle of the shark depending on which angle the turtle is facing. And we're going to notice that this is going to look a little bit funny. So in the update method of the starfish collector class, let's add a little bit more code. Right, let's add, let's maybe do this after processing the input. Let's say if the turtle.x is less than not.x, but rather .position.x, is less than shark.position.x. Right, in that case, we want the turtle to look in the other direction. And so we'll say shark.setAngle to 180. And that angle faces to the left. And if the positions are reversed, if the turtle is to the right, I'll have the shark set its angle to 0. All right, let's save and run and see how this looks. Again, you might notice something odd. All right, look at that shark. It's looking at us, but notice how it looks upside down. Right? When it faces to the right, it looks fine. Right? But rotation doesn't produce the effect that we want. Right? Again, since for the turtle, we're looking straight down upon the turtle, we've got like a perfect top view. The turtle looks fine when we rotate it. It's facing the correct direction. And because of the symmetry in its design, right, the top-bottom symmetry, it doesn't appear reversed. But for something which is Sprite, which is more of a side view image, right, it doesn't suffice to just rotate it. Instead, in this case, we'd like to mirror image it, so it looks like it's facing the correct direction. And so that's why we need this functionality, to make this look a little bit better. So in order to do that, we're going to go over to the Sprite class, and we're going to add a little bit more code. We'll add some Boolean variables that determine whether or not something should be mirrored or flipped, and we'll take that information into account when we get to the draw function. All right, so first up at the top here, let's add a public Boolean mirrored, and that determines if we're going to reflect it along the x direction. And reflect along x direction. And then let's also do a Boolean to indicate reflection along the y direction. We'll call that public Boolean flipped. Now, by default, let's say we don't want to do either of these. So for the Sprite, let's initialize those both to false. So mirrored equals false and flipped equals false. And so we've taken care of these in the constructor. Let's go ahead and go down to the draw method. All right, this is a big class. Okay. So what we'd like to do now is do some multiplying here. Right, so again, these values here, they represent kind of coefficients that are getting multiplied by the x and y position values. And so what I'd like to do is create two new values. And let's say double mirrored equals 1. And then, if I don't want to use mirrored, let's say, if I want to be technical, I should call this scale in the x direction. And then if we're mirrored, right, if mirrored is true, then scale x equals -1. Right, so scale x could be used in theory to stretch or shrink an object in the x direction, but we're really just interested in reversing it. Right, so in this case, we'll multiply all the image pixels x by -1 in that case. Right, and since right now the sprite is centered, or since the center of the sprite is the x and y refer to its center, scaling is just going to reverse the position of the pixels along the x-axis. Right, so what we need to do now is multiply these first two values by scale x. And scale x will either be positive or -1. By default, +1. Similarly, we need to set up a scale y. Right, that's something we'll multiply the y coordinates with. By default, it will be +1, but if flipped is ever set to true, we'll multiply those y pixels by -1. Right, so this will be scale y times negative sign. I'll put that in parentheses, that's a little bit clearer. And scale y times cosine. Excellent. So that's what we need to take scaling into account. And by scaling, again, we're not going to use this to change the size. That's what we wrote width and height for. But again, scaling in this context can be used to reverse the way pixels are displayed. So now let's go back to our game and let's use this to make that shark look in the correct direction. So back in starfishcollector.java, now let's say if the turtle is to the left of the shark, in that case we want to mirror image it. So shark.mirrored will be true. Otherwise, if the turtle's position is to the right of the shark, we want to return it to its original state, in which case we set mirrored to false. And now the shark should be more responsive to the position of our turtle, but in a better way. Let's go to run, and let's see how this looks. And hopefully the shark no longer appears upside down according to our perspective. And sure enough, that angry little shark is glaring at us. It is a little shark. Our turtle's almost as big as it. But then if we go to the right side, yep, it flips. It's still looking at us. And so we've got a much more responsive shark now. Excellent. All right, so the code is looking good. Next, we're going to talk about something called opacity or transparency to make this look a little bit better even. But for now, this is some good progress. We'll stop here, and thanks for watching.